they have the questions and the answers in here, and not just the answers, but like explanations of the answers. That's why I like using this one when we're reviewing. Okay, so the first one says the regression line of the two variable data set given above is y hat equals 2 plus equals 2.35 plus 0.86x. What is the value of the residual of the point whose value x value is 29? So it's asking you to solve for a what? Residual. Well, how do you find a residual? Which one of those do I have right now? Observed. So here's my x. So there's my observed. I just plug it in to get my predicted, which is 27.29 or 28, something like that, right? And so you get that. So here's your answer. The fact that it is negative just means that it was a what? Overestimate. All right, this is a tricky one. A study found a correlation of R equals negative 0.58. Well, that in itself means what? What does that tell me? Slope's negative relationship. What does 0.58 mean? That's a pretty weak relationship. Maybe moderately weak. Gotta stop. But it does say the more hours spent watching television, the less hours spent exercising. Even though it's a weak relationship, it's negative. So, what stands out about A? One word. That usually tells us what? R squared. Okay, we're done with R. What about B? So, as this goes, what? This goes, is that what this is saying? But what's wrong with that? That's just the overall idea of what's happening, especially with a weak relationship. For each hour spent watching, what does this one look like it's saying, just by those first couple words? Cause and effect relationship. When's the only time we can determine that? And then what does this one look like it's talking about? Trying to say R squared, but it's not really there. So this is our number for R, but the negative, so that's definitely wrong. This one, it's not saying it definitely will. This one's trying to apply it to slope. We don't know that it's an experiment. So why does A work if it's R squared?
You said it wasn't C because it was positive instead of negative?
No, because this is not the slope.
Oh, okay.
So why does A work if A is talking about R squared, but we're dealing with R? It actually, which is about a third, and that's your sentence for it. So that was actually our answer here. Number 4, if it says this, I do what? Plug it in, but our equation is this, so at the end I'll have to do what? E to that, so 1.64 minus 0.88, 3.1, which gives me negative 1.08. Is that right? Is that right? And then, so I take that now and have to do this to it, which gives me, which is positive, right? So C. And I'm spending time going over these pretty slow because these are really good multiple choice questions for this. Consider the following residuals plot. Which of the following are true? I think this one is kind of a tricky problem. This is the residuals plot. We want to check the residuals plot for three things. What's the first one? No pattern. The second one? Equally scattered above and below for all values of x. And then what's the third one? Relatively small. We don't see numbers, so we really can't check that one. But there's definitely no pattern.
I was confused about their evenly spread.
Yeah. So like this scatter throughout is about the same.
When it's asking evenly spread, does it mean like 5 on top, 5 on the bottom?
No, it means it doesn't want something like this, because on this end they're not very spread out, and on this end they really are.
But all of those are pushed together on the top.
But it's not. This is saying that I did a really bad prediction on the left side and a really good prediction on the right side, and it's incorrect. So the residual plot indicates that a line is a reasonable model. So if all the three things that we checked off for a residuals plot check off, then that means that the data is what? So the residuals plot indicates that a line is a reasonable model. Does that seem like yes or no?
Yes.
The residuals plot indicates that there is no relationship between the data. Well, that contradicts what we just said. The relationship between the variables is probably non-zero. And this is one that some people have to think through, because if the relationship, this one will help more today to understand too. You can kind of think about it like, well, no, I can do this. Correlation is -1 to 1. If it is 0, anywhere around here, what does that mean? It's a weak or almost no relationship. So this is saying, if there is no relationship, would this work out?
No.
Does that make sense? I'm kind of saying that weird. I can go back and say that again. If there's no correlation, this isn't going to work out right to check off that it's linear. So because this checked off and said it's linear, well, it's either a positive linear or a negative linear. This would say it's not linear at all. So that contradicts it. So the correlation is probably not 0. So C is your answer.
So wouldn't correlation being non-zero be the same thing as no relationship? Or
Yeah.
would correlation being 0?
Yes. Yeah. Mm-hmm. What you're saying?
So
Yeah.
2 and 3 out.
Thinking about 2 and 3. Yeah. 2 and 3 being opposite. Yes. All right. Suppose least square regression line for predicting weight in pounds from height is given. Which of the following statements are correct? I want you guys to realize that this is the same thing that we wrote, but when we usually write it, we usually write and then we write is that saying the same thing? It's just, instead of defining it later, it's just defining it within the problem, and that's fine. I don't like doing that because if it gets wordy, it's really hard and strange to try to draw that hat over it, but you'll see it a lot in like textbook examples. So this first one, if I plug in 61 inches as my x, do I get 104.6? Yes. What does this one actually say though? So if somebody is 61 inches, they're saying they absolutely have to be this weight. No other options. That's our prediction, but that doesn't mean they have to be that height or that weight. For each additional inch of height, weight will increase. But this one says on average. Well, on average is like when we say what instead? About or predict, that kind of thing. Is this talking about the right thing? Yes, that is slope, and that is our slope. There is a strong positive linear relationship between height and weight. What of those three do I know is yes? Do I know that it's strong or linear? Just based off the equation? No. So I can't tell those two So B is my only option. Least square regression line for predicting performance on college entrance exam based on high school GPA is determined by the following equation. One student in the study had a high school GPA of 3.0 and an exam score of 510. So this is his what? Observed. And it wants to know the residual, so we have to do this minus predicted. So you're just plugging in 3.0 to that equation, and you get and subtracting that gives you negative 37.1. So kind of surprised me that they did two questions on here that were pretty much the same thing. Correlation between two variables. I heard a lot of good conversations about this yesterday. And you guys did very well working through this in both my classes, but I want to talk about a different way to look at this too. A new set of scores. So we've got two variables, x and y, and the correlation is negative 0.26. And then we're going to adjust them, and we're going to make our x now be negative, and we're going to adjust our y's to be y plus 12. Which one of those does nothing to our r? Y plus 12. It does not care about converting units like that. You could think about it like if these were on a graph and this were 10 and this were 20, and I added 12 to each of those. Then nothing on that graph is going to change, and that's R doesn't care about that. But what happens here?
Wait, why would those values not change?
Like those dots didn't move at all just because I changed where the values are.
I thought they would move that way.
You could just change the scale. Like their relationship together stays at the same place.
But it would move up, right? Or down?
But all R cares about
In
is
relation to each other, yes.
that. There you go. So here instead it switches it. So it was negative, so now it is positive. This is an easy one to think through, but I want to show you a way that you can think about this. Because there are I've seen problems that are a lot like this, but a lot trickier and ones that you have to think through a lot more than just the one we just did.
So the y told us that it was still 0.26 and the x was positive?
Yes. The y didn't change anything, but the x switched the sign. Changing the x to negative, switch the sign. All right, so what I can do here is, I already have numbers typed in. I didn't really want to do this. I'm going to plug in some numbers in my calculator and just get a regression line. And it was initially negative, so I'm just going to type in 1, 2, 3, 4, 5, and 18, 15, 13, 9. So I just plugged in, I know I'm in list 3, list 4. I plugged in something to where these go up and these go down, so I'm going to get a negative relationship. And I'm going to do stat calc 8 of list 3 versus list 4 because it's where I am. And right now, this gives me an R of negative 0.9917.
Whenever you do for your thing you're doing that let's do the score, you do go change the stat plot to the same?
Depending on what you want to graph, yes. So now I am going to use my calculator to go and change the things it just told me. So in list 3, I want to switch my list 3. In list 5, I want to switch the x's the way it told me to. So what am I going to put in list 5? Negative list 3. And then what am I going to put in list 6? List 4 plus 12. And then so I've got my new list. So this is the negative x's. These are my y's plus 12. And then do stat calc 8 of list 5 versus list 6. And then let it do it again. And my R is now the exact same thing I started with, but positive. So this is a good, like right now, I think you guys are good with this. but come May, you might be like, I don't remember what's going to happen here. And this is an easy way to double check to see what happens in this type of problem. And this is the kind of thing I would typically use a lot just to check things. So just showing you a different way to kind of go about that same problem. A study was done on the relationship. It gives you all the X and the Y. It's asking about percent of variation. So it's asking to find your what? R squared. Well, if it gives you all the values, then you're going to do what with them? Plug them in your calculator and let it find R squared for you. And it ends up giving you R squared is 0.7881. So E is your correct answer. So this is just understanding that it's R squared and how to find it in the calculator. And the last one, now, what are our X values here? One word. One word, what's our X values? What is generally our Y's? It says the mean weight for the vehicles in the study is 200 or 2,980. That's our what? What's the only thing in this whole chapter that we talked about with X bar? This is going to be a point on your least squared regression line. So to find that, I just plug that into my least squared regression line and find out what it predicts it to be. So you're just plugging in this value to get that value, and it ends up being, oh, and this is the second thing. What are our units for weight? So what do I actually plug in as my X bar? How many hundreds of pounds is that? $29.8. And so that's what you're plugging in. So you should end up getting 19.09 as your Y bar, which is A. Questions on any of these?